Welcome to Econ 317. In this instruction video, we will go over additional examples of derivatives and we will also learn rules of differentiation. So let's start with some additional example. We have already seen for y equal to f of x, the derivative given by x to the power n, the derivative is n times x to the power n minus 1. And we saw for different values of n how the formula is applied. Let's look at some additional example. First one, y equal to the e to the power x. This is the exponential function and the derivative is the function itself. So for e to the power x, the derivative is e to the power x itself. Then I take an example of the logarithmic function y equal to log natural of x. The derivative is 1 divided by x. Okay. We also have seen the trigonometric functions, even though we may not be using them a lot in economics courses, but it is good to know the derivative of at least the trigonometric functions, at least two. I will go over the derivative for sine of x. So for sine of x, the derivative is cosine of x. And for the cosine of x, it is the negative of sine of x. Cosine of x, the derivative is negative of sine of x. I'll also like to write down the derivative for a function which can be written as y equal to a times f of x, where a is a constant as the derivative being a multiplied by the derivative of f of x. And for this I'll give an example. Let's consider y equal to 2 x to the power 1 half. Then the derivative is 2 times the formula, the derivative of x to the power 1 half is 1 half times x to the power 1 half minus 1. And you can see there is a simplification going on. 2 times 1 half is 1. And I have x to the power minus half. Usually we don't write 1. So I could write it as x to the power negative half. Or I could take the term in the numerator to the denominator. The power will become positive, which is same as writing. So this is a useful formula to learn. Now I will go over at least 3 rules of differentiation. First, the derivative of a sum. Derivative of sum of two functions. So let me take y equal to f of x plus g of x. For this, the derivative dy over dx is the sum of the derivatives of each one of these functions. So derivative of the first function, derivative of the second function, and that's what will be the derivative of the sum of the two functions. So for example, if I take y equal to x to the power 1 plus x to the power 5, so you can see f of x, the first function is x to the power 1. The second function is x to the power 5. Usually when we write x to the power 1, we don't include the exponent. So I could have written f of x to be x itself. Then I'll find out the derivative of each one of the two functions. First one is derivative of x to the power 1. The rule is I take the exponent to the coefficient and then I reduce the exponent by 1. So this is 1 times x to the power 0, but we know any number to the power 0, any non-zero number to the power 0 is 1. So the answer is 1. The derivative of the second function is, so this is x to the power 5, 5 times x to the power 5 minus 1, which turns out to be 5 times x to the power 4. And so the derivative of the sum of two functions is sum of these two derivatives. So derivative of f of x with respect to x, derivative of g of x with respect to x, and they turn out to be 1 plus 5 x to the power 4. Okay, so that's the first rule of differentiation, derivative of sum. Now we will look at derivative of product of two functions, or product of two functions. So I have y being defined as product of f of x times g of x. F and f, g are two distinct functions. Then the derivative, this is the product rule, first function times the derivative of the second function plus the second function times the derivative of the first function. So that's the product rule. I can give an example. Consider y equal to product of two functions. So let me take f of x to be x to the power 4, g of x, x to the power 7, and then we will apply the product rule. So y is f of x times g of x. The derivative of f of x is derivative of x to the power 4, which we can see now, 4 times x to the power 3. I subtract 1 from 4 to obtain 3. Derivative of the second function is derivative of x to the power 7, which turns out to be 7 times x to the power 6. And now I'll apply the product rule. So derivative of y with respect to x is the first function, x to the power 4, times the derivative of the second function, 7 times x to the power 6, plus the second function, x to the power 7, times the derivative of the first function. And now we can simplify. The first term turns out to be 7 times x to the power 10. 4 plus 6 is 10. The second term turns out to be 4 times x to the power 10 again, because 7 plus 3 is 10. And now I can add these two terms. They have similar power. So 7x to the power 10 plus 4x to the power 10 becomes 11x to the power 10. Remember, I could have applied the formula directly for the derivative of this function, because we know when y is defined as product of x to the power 4 times x to the power 7. I know it is x to the power 11. So just to verify whether we get the same derivative, by applying the product rule, I can check. Derivative of x to the power 11 is 11 times x to the power 11 minus 1, which is 11, x to the power 10. One additional rule of differentiation is the derivative of a quotient of two functions. So let's have y equal to f of x over g of x, where we must ensure the quotient is well defined, which means g of x must be non-zero. And now I will write down the formula for the derivative of the quotient. So dy over dx is the function in the denominator g of x times the derivative of the function in the numerator minus the function in the numerator times the derivative of the function in the denominator, and then I divide it by g of x square. So this is the formula for the derivative of a quotient function. So let's apply this for an example. I will take f of x to be x to the power 4 and then g of x to be x to the power 2, and then let's see if we are able to apply this formula. So dy over dx is the function in the denominator x square times the derivative of the function in the numerator 4x to the power 3 minus the function in the numerator x to the power 4 times the derivative of the function in the denominator, which is 2x, and then divided by the denominator function squared. So let's try this. This turns out to be, the first term is 4 times x to the power 5 minus the second term turns out to be 2x to the power 5, and then I divide it by x square whole square, which is x to the power 4. So now you can see we can simplify the term in the numerator. 4 minus 2 is 2x to the power 5. I divide it by x to the power 4. I obtain 2 times x. Remember, I can verify this to check whether the formula gives us correct answer. In this situation, y is equal to x to the power 4 divided by x to the power 2 turns out to be that it can be simplified to be y is equal to x square, and we already know the formula for the derivative of x square is 2x. So this is just to confirm that the rule works exactly the way it is intended to be, and this is a good point to stop.